Chapter 2.2 talks about three dimensions. We're going to deal with the coordinate system with three dimensions, and we're going to then eventually get into vectors. So our coordinate system has an x, y, and a z range, so for three dimensions, and as you note, it's often denoted by this r cubed, which is that r is a symbol for the real numbers. So they look like this. That's the real number line, or the notation for the real numbers. R squared is in 2 dimensions, and R cubed is for 3 dimensions. And simply R that we have up here, that would be 1 dimension, just the normal number line. All right, so on the right there, I've got a picture of what the axes might look like for a graph for 3 dimensions. And say we want to plot the points 2, 0, 1. So our first value is the x value, our next value is the y value, our third value is the z value. So x of 2 is over here to the left, and there's no y component, so we're not going to move down any, but we need to go up 1, so maybe here-ish would be this point. All right, some problems that we might want to deal with. Write the equation of the plane passing through the point 1, 1, 1 that is parallel to the xy plane. So if we draw a little graph here, and we want to plot the point 1, 1, 1, well, where to draw this? I mean, it may kind of match up with the origin. Maybe it's something like here, maybe it's above, whatever. But we want to be parallel with the xy plane. The xy plane is this area down here. So we want to be essentially 1 above it. So it looks like any points are going to work as long as the z value remains 1. So this answer is just z equals 1. In a similar fashion, number 70 on the right, find an equation of the line that passes through those 3 points. If you notice, the x value is 1, the x value is 1, and the x value is 1. The y and the z's change to whatever, but we're only worried about where x equals 1. We're making a plane through the value x equals 1. So here just x equals 1. That's the equation for that, at least the equation for the plane.